basically we are doing recap of this concept, which we can say finding work done, finding potential energy, or maybe finding potential difference, or maybe finding electric field, or maybe finding force.
Yes, sir.
Basically, we are using all of the physical quantities, and in the question, any physical quantity can be asked, given other physical quantities, and ask one particular physical quantity. How they are all interconnected is what I wanted to discuss. Okay, so basically we are doing the recap of, let's say, the uh, interconnectivity. Okay, it's not so apt, but basically how all of these physical quantities are connected. If electric field and distance is given, how can I find potential difference? Or if it can also be a variable, or if electric potential and charge is given, then how can I find the potential energy? From there, how can I find the potential energy difference or work done? And from there, if distance is also given, I can find force. So all these physical
Is
quantities
there
are
any relation between all those four physical
all
quantities?
the four physical quantities, right? And the fifth one will be automatically work done. Okay. So
Yes, sir.
here is the story. So suppose I have a electric field in this direction. Then I chose 2 points P and Q. Line PQ is parallel to the lines of electric field lines.
Yes, sir.
Okay. Now, if we place a positive charge at point P, a positive point charge at P, due to the electric field, there will be an electrostatic force from P to Q.
Yes, sir.
And this electric field will take this charge from P to Q in a
Yes, sir.
given time, in a given time dt, right?
Yes, sir.
In a given time dt. Okay,
Yes, sir.
it will take some time. Time is not important for us, because once we come to time stories, it is kinematics. V is equal to U plus AT, or A is equal to dV by dt, depending on if it's a variable or if it's a constant acceleration. We have our equations in kinematics, right? So
Yes,
how
sir.
much time it has taken from P to Q? 5 seconds, 10 seconds. We are not interested in that. We are interested in our 4 or 5 physical quantities, which is force, field, potential energy, potential, and work done, right?
Yes, sir.
So what is the story that we have? There is an electric field, uniform or non-uniform, does not matter. And in that electric field, if I place a point charge plus Q at P, there will be an electrostatic force acting on this charge parallel to the electric field, and it will make the charge move, and we are studying it from P to Q. Okay,
Yes, sir.
here who is taking the charge from P to Q? Electric field is taking the charge,
Yes, sir.
in the sense that no external agent is actually doing anything.
Yes, sir.
So we don't have to worry about any external agent doing any kind of work. All the things are happening automatically. Only the point charge was placed over there. Okay.
Yes, sir.
Second thing I told you, which was the first thing yesterday, that this electric field we tend to get confused that from where is this electric field coming. So we are not bothered about from where the electric field is coming right now. This electric field is coming from a source, and the source is not given to us, and we don't have to bother about it. So two informations are given. There is a parallel beam of electric field lines. Second information is there is a point charge plus Q placed at point P, free to move. That's all.
Yes, sir.
Rest stories, whichever is going to happen automatically, and there is no third party intervention in that. Okay.
Yes, sir.
Therefore, if this point charge is moving from P to Q, and let us say PQ bar, I will take it as R bar. We can take it as R bar, or if it is infinitely small, we can write it as dr bar, because we are right now not saying if it's finite, infinite, it doesn't matter. We can take either of them. And my point here is, you take R bar or dr bar, the science will exist. The physics behind it will always exist.
Yes, sir.
Now, first I started off by saying that work done due to that electrostatic force is basically F bar dot R bar.
Yes, sir.
Correct?
Yes, sir.
Work done is nothing but F bar dot R bar. Now, we can write force vector F bar is equal to charge into E bar. Right?
Yes, sir.
So, in the place of force, we can write it as charge into E bar dot R bar.
Yes, sir.
Correct?
Yes, sir.
So, we can keep this scalar fellow outside and put that fellow in bracket. Nothing different. It's just the same. Okay?
Yes, sir.
Next. Work done also is negative of change in potential energy.
Yes, sir.
I have a doubt. Why is it negative? Why is it not positive?
Sir, if you consider with respect to the force, then whatever the work force is doing, like, I mean, it is giving energy to the system, so it is losing energy within itself. So the work done will be negative.
Good. We can say like that also. In fact, that is the most appropriate way of saying that, because energy of the system is losing its energy, which is potential energy. So whatever energy is lost, and change in physics is final minus initial. It has to be
Yes.
negative, therefore it is negative, therefore correct. Good. So this delta U is negative, but work done by that is positive, so negative into negative will be positive. That's why I want this negative sign. Good. And the way to remember is, because there is a chance of confusion, I am saying it, although your explanation is actually the right one. Okay. The way to remember is that for same source, work done will be negative of change in potential energy.
Yes, sir.
Why I said that is because if there are multiple sources, which usually are, so what is the work done by the system? What is the work done by the external agent? All these stories usually come up. So work done by the external agent is positive of change in potential energy of the system, or negative in change in potential energy of the external agent. That's what we said.
Yes, sir.
Right? So if the source is same, negative sign will come. If the source is different, then the positive sign will come. That's how we remembered it. And the meaning of how to come to the conclusion is your explanation is actually correct. Energy system is losing energy, delta U is negative, work done is positive. I want delta U negative, that means negative. I want another minus sign so that work done will become positive. Correct? Okay.
Yes, sir.
Now we also had a definition that electrostatic potential energy is equal to charge into potential. Right?
Yes, sir.
So here I can substitute that as minus delta. In place of U, we can write it as Q into V. Again,
Yes.
we can take the Q fellow outside. So I can write it as Q times of minus delta V. Right?
Yes, sir.
So comparing these two equations, we can come to one conclusion saying Q times of minus delta V is equal to Q times of E bar dot R bar. That means minus delta V is equal to E bar dot R bar. Correct?
Yes, sir.
Delta V, what is delta V? Delta V is nothing but this is initial, this is final position in our story. So delta V is actually VQ minus VP. Okay. So I am going to substitute over here minus of VQ minus VP.
Yes, sir.
We can take the minus sign outside and write this fellow as VP minus VQ is equal to E bar dot R bar.
Yes, sir.
This is if there is significant change, significant in the sense something like 20 is equal to 20. Non-calculus thing. But if I have calculus story, the same thing I can write it as, or the same thing I can write it as from here only, minus dV is equal to E times dr. Correct?
Yes, sir.
Or I can say that E is equal to minus dV by dr is what I will remember.
dr by ESRT.
Okay?
Yes, sir.
Next. After this, what we discussed was the system always goes from high potential energy to low potential energy. That means the potential energy of P is greater than potential energy at Q of the system.
Yes, sir.
If I will use this definition and substitute, Q will get cancelled and it is anyways positive. Therefore, I can say the potential at P is greater than potential at Q.
Yes, sir.
So what we are trying to say is that whenever there is a field line, in the direction of field line, potential will decrease. Therefore, VP is greater than VQ. Correct?
Yes, sir.
Next, I chose another point R, and if we join this PR, basically PR is perpendicular to our electric field.
Yes, sir.
We said the effect of any vector in its perpendicular direction is 0.
Yes, sir.
That means the electric field in the direction of PR is 0. There is
Yes,
no
sir.
electric field in the vertical direction. Correct?
Yes. Yes, sir.
If electric field, no electric field means 0.
Sir, but then, yeah, but then if you take the field above it also, then there'll be some electric field between here.
There will be electric field everywhere in the 3 dimension. but the direction of electric field is I cap.
Okay. Okay, sir.
The electric field along J cap is 0.
Yes, sir.
Because the electric field along vertical line is 0, here I can say that E is 0.
Yes, sir.
When will electric field be 0 according to this?
When dV by dr is constant.
Is 0. dV by dr is 0.
Yes, sir. Yes.
When V is constant.
Yes, sir.
So if electric field is 0, that means the potential along that PR is constant, right?
Yes, sir.
That means the potential at P is equal to potential at R. Right?
Yes, sir.
That also means that I can say this PR can be said equipotential line or surface.
Yes, sir.
In 3D I have a surface, in 2D I have a line. But equipotential is the important factor over here. Clear?
Yes, sir.
See, this definition and this definition we already, that is definition, so we already know that when we were doing the chapter. Correct? So what is the conclusion that we eventually made from all of this? Is one of the thing is work done, I can write it as this fellow, charge into negative of change in potential. Right?
Yes, sir.
This is one. Work done is negative of change in potential energy, that we already know. That is not a problem. Right?
Yes, sir.
The next thing that we came to look at is basically E is equal to minus dV by dr, which is also an important thing.
Yes, sir.
Extra points which I did not mention yesterday was this E is equal to minus dV by dr. I can write it in our Cartesian coordinate system, meaning I can say specifically Ex I can write it as dou V by dou X. Ey I can write it as minus dou V by dou Y. And Ez I can write it as minus dou V by dou Z. When does this dou fellow come?
There's a partial differentiation, but I don't know where.
We only know that dou is basically named as partial differentiation. We don't know why it is so.
I mean, if there are two different variables, then we can use it.
If a function A, like you said, multiple variables, if this A is dependent on B, C, D, E, F, that means this is a multivariable function.
Yes, sir.
If I want to study the variation of A due to one individual variable, see, if I vary B, A will change. If I vary C, A will change. If I vary D, A will change. If I vary E and F, A will change. Right?
Yes, sir.
I can vary multiple things also.
Yes, sir.
But if I want to study the effect on A due to variation of each,
yes, sir.
Then first of all, whenever we want to study any kind of a change, we use differentiation, not integration. Differentiation, we have a form of dy by dx.
Yes, sir.
So you're actually not confused about d of something divided by d of something to be here. We know in differentiation, it is always in the form of dy by dx. We are only concerned about why is this dou written. because my A is dependent on multiple variables. But if I want to study the effect on A just by varying, then I will do dou A by dou B.
Yes, sir.
That is where I will use dou.
Yes, sir.
Is it clear?
Yes, sir.
Fun fact,
We put everything constant except
every other variable we treat them as a constant and treat only B as a variable and then study it like that. Right?
Yes, sir.
So suppose, I mean, this is not much of a difficult thing to understand, because suppose you have a building,
Yes, sir.
okay, and you have your dog. So first of all, the building has some x-axis, and let's say xy axis is the ground, so some x-axis, some y-axis. So this becomes the xy plane.
Yes, sir.
Right? And
Yes.
there is a building, so z-axis also.
Yes, sir.
Now along x-axis I have grass. So dog whenever sees grass, its activity is 1.
Yes, sir.
Along y-axis, let us say there is complete food. Dog's activity when we go along y-axis is completely different.
Yes, sir.
Are you getting my point?
Yes, sir.
Now if you leave the dog, this is only xy axis, I'll come to z axis. If you leave the dog, it will not just run along x-axis and y-axis, right? That is a different thing. That it never does that, obviously. It will see something over there, run over there, run over here. So it will run in a very random curvature. But whenever it comes to grass, it is interested in peeing on it. And whenever it goes to food, it is interested in eating on it, irrespective of what is happening in the world. Irrespective of where the dog's owner is, and if the dog's owner is being, beaten, theft, whatever, this fellow is busy, right?
Yes, sir.
It's a basically Pomeranian, okay, or that Chihuahua kind of a thing, whatever. Okay, so what I'm trying to say is that this mathematics don't feel as if mathematicians have done very amazing thing or anything. It's a very common thing. So the dog example is along x-axis there is grass. Dog's activity is one particular activity. Along y-axis there is food. Dog's activity is a second particular activity. And if I leave the dog, so whenever the dog is varying along x-axis, it will have one activity. Whenever it is varying along y-axis, it will have another activity. Because it being a dog, first he will run a little bit in the grass, go there, eat something, run back to the grass, do something, go there, eat something. How it is running here and there, God knows. Unless and until we hold it and take it only along x-axis, then only along y-axis, it will do those functions accordingly. Otherwise, this is how it is going to behave. Right?
Yes, sir.
Now the third function, because it is a building, suppose I will take it to 5th floor. Dog's only job to do from 5th floor is watch and bark, irrespective of anything. Crow is flying, bark on it. Okay, so it's okay. I mean, crow is also, living its life, but dogs are interested only if they're on 5th floor, right? When it comes to ground floor and if it sees the same vehicle, now it will stop. Oh, but if you put it in 5th floor, it will keep barking. So the altitude function is varying its barking levels. From 10th floor, it will bark even heavily. From 1st floor, it is shit scared. Maybe that fellow will jump and come and kill it. Okay, so the idea is along x-axis it has a function of peeing. So if I do do dog divided by do x-axis is equal to peeing. Do dog divided by do y-axis is equal to eating. Do dog divided by do z-axis is basically barking.
Yes, sir.
Are you getting my point? So
Yes.
individually, if I want to study the variation of A due to individual variable, then I will use this do so that we get to know all other functions are the same, how we are going to differentiate and all the rules of differentiation are the same. Only we will get to know that this is a multi-variable function.
Yes, sir.
That means when I write it like this, I can clearly see that all three x, y, and z, all three physical quantities are involved in it. Electric, we haven't done electric potential due to hollow sphere. Okay. So, simply easy thing. We have already discussed electric field due to a hollow sphere, right? Inside a hollow sphere.
Yes, sir.
Right? So, electric field inside, let's say there is a hollow sphere of charge capital Q and radius of capital R. Right?
Yes, sir.
So, electric potential due to hollow sphere, we divided it into two regions. One is inside the hollow sphere and other is outside the hollow sphere.
Yes, sir.
Right? So first we will focus on what is the inside story. Okay.
Yes, sir.
For inside, you already know that what is the electric field inside a hollow sphere.
We have to check.
By the way, this is uniform distribution.
0, sir.
Good. Okay. Uniform or non-uniform, it will eventually be 0. So we are dividing this into two regions, right? Inside and outside.
But then for the potential, it won't be 0 because it isn't a vector.
We'll come to that.
Yes, sir.
So right now we are focusing on the inside story, right?
Yes, sir.
Is it clear? We are only focusing on the inside story. Inside story, we said electric field is 0.
Yes, sir.
But just now we saw electric field is minus dV by dr.
Yes, sir.
If electric field is 0, that means what are we getting from here? We are getting that the potential has to be constant.
Yes, sir.
Correct?
Yes, sir.
How much it should be? We don't know. We only found out that it should be a constant, right?
Yes, sir.
How much it should be, we will find out. But first let us do outside. Okay?
Yes, sir.
We will do outside and then again come back and see how much it should be. For outside, suppose at a distance of r from the center, what is the electric field due to a hollow sphere at a distance r outside of hollow sphere?
I don't remember.
Kq by r square. Because the hollow sphere,
yes, sir. Yes.
hollow sphere will behave as a point charge placed at its center.
Yes, sir.
Hollow sphere will behave, you should remember this statement. This is a very common and important statement. Hollow sphere behaves as a point charge placed at its center. Point charge capital Q placed at its center. So it is kq by r square. Okay?
Yes, sir.
But again, you know that electric field can be written as minus dV by dr. Okay?
Yes.
So let me do integration part of it. So minus dV is equal to, I'll cross multiply, kq is constant dr by r square. Is this correct?
Yes, sir.
Integrate on both sides. I am doing indefinite integration and I'll not be bothered about the constant also. Usually indefinite integration, we take a constant, right? So I'll just write this as whatever integral dv is v. Okay, so minus v is equal to what is integral of dr by r square? 1 by r square.
Minus 1 by r.
Minus 1 by r. So I can write it as minus kq by r. Correct?
Yes, sir.
That means minus minus cancel. The electric potential can be written as kq by r. Is this clear?
Yes, sir.
There's another way to solve this. What is that way? Take an element. The element for a hollow sphere is circle, ring.
Yes, sir.
At an angle theta, take an element. Theta varies from 0 to 180 degree. Then the entire of hollow sphere is taken care of. Do all, find dv, dq, substitute, integrate. Eventually we'll come.
Yes, sir.
Eventually we will have to come here, right?
Yes, sir.
Here also I am showing you why this E is equal to minus dv by dr is an important and easy concept. Are you getting my point?
Yes, sir.
Simple. Or else we'll take that element, describe the
It will
element.
take minimum 15 minutes.
Yeah, exactly. Right?
Yes, sir.
Describe the element first, because this is a aerial distribution. You will have dA.
Yes, sir.
That radius will be r sine theta. Adjacent is r cos theta. So 2 pi r sine theta into r d theta. And what is the electric potential due to that? All that stories.
First integration of a point, then we get a ring. Integration of
Then this was pretty straightforward, right?
Yes, sir.
Xerox. Oh, by the way, wait. The electric potential outside, we got it as kq by r. Okay.
Yes, sir.
Let us just see what will be at surface. See, at surface, we can't define it as outside, inside. We don't know if at surface is. I don't know if I am inside Earth or outside Earth. I'm not very
Yes.
sure, right? Because I am exactly at the surface, right?
Yes, sir.
At surface, my smaller is basically capital R. The electric potential at surface is
kq by capital R.
Capital R. Okay. Now, understand. Let me write it as Vs, a potential at surface. So everywhere at the surface, the electric potential is Vs. Correct?
Yes, sir.
Everywhere I have. Now we need imagination from it. Everywhere I have Vs. And we are saying inside everywhere it is constant.
Yes, sir.
So suppose I am at this point. What is the potential? Vs. Okay. Slowly I started going inside.
At 12 degrees.
It will be?
No, it should increase.
Increase?
I don't know, sir.
Why should it increase or decrease?
I mean, you told it is a constant. But if you go inside, the value might change.
Then why did we say it should be a constant?
That is at the surface also. I mean, at surface we will have one constant, inside we'll have other constant.
Good, correct. That's what I am saying. So I am at surface and the potential over there is Vs.
Yes, sir.
Now slowly I walked in. What should be the dependent parameter on the basis of variation of potential? Why it should happen? See, you are saying it should be something different, right?
Yes, sir.
Okay, I want to agree. I want to get convinced. So if it is different, suppose at the surface it is 10. So inside it might be 9, 8 or whatever, or 19 or 18, whatever it is.
Yes, sir.
Now, There are only two chances. One is it should increase or it should decrease.
Yes, sir.
If it is not the same. If it is
Yes.
increasing and decreasing when we are going inside, then why am I writing it as it should be a constant everywhere?
The inside part, it will increase or decrease, but it will maintain the same value.
Correct. So basically, you are speaking like Arnab Goswami. Inside part will increase or decrease, but it will have the same value. First we are talking of the first half only, increase or decrease. Why should it increase or decrease is what we are talking of. Will remain the same value is the next part.
Because there is change in radius.
Because there is change in radius. So how should it affect the potential? Radius is a geometry.
But it is dependent on R.
What is dependent on R?
The potential is KQ by R.
Potential is dependent on R.
Yes, sir.
Is it dependent on R inside or outside?
What is it?
You said potential is dependent on R.
Okay, if it is 0, then inside it won't be dependent, sir.
Inside it won't be dependent. So from the surface, if I go outside, it is dependent. From the surface, if I go inside, it is not dependent.
Yes, sir.
My point is,
dV by dr is 0. So dr can't be 0.
dV by dr is
0. Dr can't be 0. It's in the denominator.
okay.
How will you take that, sir?
dr cannot be 0. Okay. There is some dr. Okay. Good morning.
One second. Yes, sir.
Yeah, so dr in the denominator is there. Okay. So what? Anyways, cut it short. Because everywhere inside is constant, whatever is there at the surface, it will carry on the same value. That's the whole point. Because as soon as, see, only the surface part is in between inside and outside. That surface part I found out as KQ by capital R.
So you're telling that if you move a very little inside, that is very negligible. So it will have the same value inside.
No, I am telling, what I am telling is that first if you listen, you will understand.
Yes, sir.
There is inside, there is outside. Only thing that is in between inside and outside is surface.
Yes, sir.
At surface, we said it is KQ by R. So from surface, if I move 1 nano inch or...
I was telling that. Yes, sir.
I know, I understood. But first you listen, you will know that I am saying the same thing.
Yes, sir.
Even if I come a very negligible distance inside, it is eventually inside.
Yes, sir.
How much ever small I go inside, it is eventually. What is the property that is happening inside, occurring inside? That the potential will be constant. So if it has to remain constant, for example, I have 10 rupees and I came home. Once I enter my home, I will still have 10 rupees, right? Only when I'm outside, there is a point of spending that 10 rupees. Once I enter my home.
Like outside the door and inside the door.
Exactly.
Yes, sir.
Door is the surface. So outside the door, there's a probability of spending, someone can come just outside the door also. But once I'm inside the door, maybe 1 inch, 10 inches, or 1 meter, or completely inside, right? There's no chance of me spending money. So if I have 10 rupees while entering the door, I will always have 10 rupees inside the door. Everywhere inside the door, I have 10 rupees.
Yes, sir.
Outside the door, even if it's small or large distance, the variation of potential will occur according to this equation.
Yes, sir.
Is it clear?
Yes, sir.
Xerox. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.